So now let's move to the workshop that we are explaining, and that is exploiting esoteric Android vulnerabilities. So before diving into the workshop, let's just introduce ourselves. So my name is Sanjay Gondalia, and currently I'm working as a principal security consultant at Not So Secure. And currently I'm having 8+ years of experience in information technology, where my specialization includes web, mobile, desktop, and the external infrastructure penetration testing. I mostly do a research and create a vulnerable application for the Not So Secure training program. And these are the well-known repositories that I owned, and that is Blacklist, Android Application Analyzer, and the serialized payload generator. So we'll see a demo around Android Application Analyzer. Along with me, my colleague is there, whose name is Sharan Sanjay. He's also a co-presenter for this workshop. So Sharan, could you please introduce yourself?
Thank you, Sanjay. I am Sharan Sanjay, Senior Security Consultant at Not So Secure. So I'm having 4 years experience in information security. I love to research, develop vulnerable apps, do a lot of things like pen testing. My specialization in web application, mobile application, cloud config review, and external infrastructure. That's about me. Thank you, Sanjay. Over to you.
Thanks, Sharan. It's a wonderful introduction. So let's jump into the workshop. Let's move to the next slides. So as this is a workshop, we have created so many vulnerable applications. So those who want to do a hands-on during this workshop can simply navigate to my GitHub page. So this is a public repositories. Let me show you that. So you can simply navigate to this BSides Ahmedabad, where I've just uploaded a Google Drive link, which contains all the vulnerable application details. Okay, so this is all the APKs that we are going to use and exploit during this workshop. So yeah, you can navigate to that. So if we talk about Android application penetration testing, we generally divide whole stuff in two parts. The first one is the static analysis, and the second one is the dynamic analysis, where in the dynamic analysis portion, we generally do a API pen testing that is communicating with the Android application, and in which we are just checking for the OWASP Web Top 10. In case of static analysis, whenever we receive the APK file, we first do a APK analysis, then we'll bypass the client-side checks that are implemented. You will find this kind of checks, especially in the production application, and that is root detection checks, emulator detection check, integrity check, SSL pinning checks, and so on. So once we are successfully bypassed this, we are able to access the application, and we are communicate with the application, and we are able to access the activities that is there within the Android application. So then we'll see a demo around how we can use the application sandbox analysis while using my tool, and that is Android Application Analyzer, which will save your time during the testing. So once all done, we can talk about esoteric vulnerabilities. So these are generally untouched vulnerabilities that generally pen tester missed. Okay, so we'll see a demo around that, how we can exploit and how we can identify those. Okay. These are the tools that we generally use. So for the purpose of this workshop, what we will be looking at. So we are not going to look at how we can do APK analysis, like use the MobSF framework, or let's say use the Drowser framework to exploit all this. But instead of that, we'll see how we can bypass the client-side checks, in which we are checking, in which we are looking at root detection, emulator, integrity, and the SSL pinning checks. So here we are talking about two techniques that is generally mostly used. The first one is the Smalley code modification, and the second one is the frida hooking. Then we'll see a demo around Android Application Analyzer, and then we'll discuss about the esoteric vulnerabilities. So in this, we'll discuss about Webview attacks, remote debugging attacks, app links, what is the difference between app links and the deep links. Then we'll see exploitation around Android file picker misconfiguration, and we'll see how we can exploit the mobile passcode using bash script. So in this, we'll discuss about two techniques, two test cases, where we first check for the text-based inputs, and the second one, we are trying to bypass the touch-based inputs. Okay. So when it comes to root detection check, so generally developer use the third-party libraries, and these are the well-known third-party libraries like rootbeer. Then there is a Firebase, in which there is a common utils the class is there, where it contains a isRooted function. Then there are certain developers, they create their own user-defined function where they create their own function to do root detection checks. So basically, they just check for all these stuffs, like it checks for the sub-binaries exist or not, is there any danger permission installed or not in the application. And based on all these stuffs, they just detect whether the application is running on the rooted device or not. And if it's so, then it just blocks the user to try to access on the Android device. And if the application is able to identify the root detection, then you usually find this kind of an error, like the device is rooted. So when you click on OK button, it will force close the application, and you are unable to access the application further, or let's say you are unable to pen test the application further. The second check is emulator detection checks. As many of us having, let's say, many of us are having using emulator instead of mobile device because it's very convenient to do a testing. So how the developer is detect whether it's running on the emulator or not. So based on the build information, brand information, or let's say device information, then there is a product information. So based on the string keywords or the string comparison, let's say if it's able to identify these keywords like generic, unknown, Google SDK, emulator, Genymotion. So based on that, it will detect the emulator, and once it's detect, it will show you this kind of an error. Let's say application running on emulator. So if you click on OK, it will not allow you to access the application. It force close the application. The next check is integrity check. Okay. So generally, the integrity check is implemented using the checksum calculation. Okay. So this is the overall architecture of how the Android convert the Java file into an APK file. So as we all know that the Android is nothing but the collection of Java files, right? So whenever we try to create an APK file, the compiler first compile all the Java file and produce the class file equivalent to the classes. Then it uses the dex compiler, which basically convert all the class file into a single collection of dex file. It's basically a classes.dex file which contains all the classes information. Then it will package this dex file into AAP. Then this AAP file is used to create an APK file. So this checksum is basically implemented using the checksum that is calculated for the dex file. Okay, and when we run this particular application, it will recalculate the checksum for the dex file. And if it's not matched, then it will show you an error for the integrity mismatch. So if that's the case, you will often find this kind of an error, and that is application integrity is tampered. So when you click on OK, the application force closed, and you are unable to do a further pen testing. And this is the most commonly error that we have identified, and that is SSL pinning. So most of us who are doing a mobile application penetration testing is required to bypass the SSL pinning checks. Okay, so this is the third-party libraries that is most commonly used to implemented by the developer to implement a SSL pinning checks, and that is OKHTTP, where the certificate pinner class is used to implement the SSL pinning within the application. Then there is a conscript library which has a class trust manager implementation, and using that, generally developer implement SSL pinning checks. If the developer fully aware about how to implement SSL pinning, in that case, they create a custom function. So when we try to configure a proxy in our mobile device, you often find this kind of an error in your, let's say, Webview event log, where it says that the client failed to negotiate a TLS connection to your API endpoints, where it receives a fatal alert and contains certificate unknown, and you are unable to access the application further. So these all checks that I have found during the journey of mobile application penetration testing. And in order to do a pen testing further, first we have to bypass all this. So this SSL pinning is generally implemented based on the checks that is SAR 256 hash that is calculated for the certificate, and it's hard bounded within the source code of the application. So at the runtime, it will recalculate, it will capture the SAR 256 hash from the API endpoints, and based on the comparison, it's throw an error. So it's demo time. So let's try to bypass all these checks. So these are the 4 checks that we have to bypass. The first one is the root detection, the second one is the emulator, then the integrity and the SSL pinning. So let me show you the basic application. So let me quickly start the Genymotion. So this is a very simple application. So if you install this particular vulnerable application, it has 2 activities. The first one is the main activity, and when you click on next button, it shows you this your secret. This is the second activity. Okay. So we have to reach out to this particular page while bypassing all these checks. So let me install the application where it contains all these checks. So it has implemented the devices, the root detection checks. So here I teach you 2 things. The first one, the first technique is Mali code modification, and the second one is the frida hooking. So there are a lot of tools are involved in order to process this. So we have to use in order to do a Mali code modification, first we have to use, let me zoom it a bit. So first we have to use apk tool.jar in order to decompile the, okay, so the first step is we have to extract the apk from Android device. Then we have to use apk tool.jar to decompile the application. Then we have to do a Smali modification. In order to test this, first we have to recompile using apk tool -build option. Then we have to sign the newly generated apk. Then we have to uninstall the existing application that is installed on the device, and then we have to install the newly generated application. So you see, there are so many steps that we have to perform in order to test this particular thing. So to save the time, I've just created a tool that is called Android Application Analyzer. You can find the source code. It's open source. Okay, so you can simply go to the company GitHub page, and that is Android Application Analyzer. You can simply use this. Okay, let me. So here is the setup instruction. And you can simply run this using the Python 3. So it's Python 3 based tool. So I already downloaded that. Okay. So let me quickly run that. So in order to run that, we have to simply shoot this command, that is python main.py. So I just try to club all the things into a single GUI-based application, where here you can see all the connected device that is connected to the mobile, the machine. So once we select the device, then over here you see all the application that is installed on that particular device. Okay, you can also use this, which basically hide all the default packages. Then you have to select the application package name. So in our case, it's com.nss.notsosimple_android app. But to give you an example or to give you a walkthrough, because this contains so many hierarchy, so I'll just using zaka.asim.diva, I'll just installed a diva vulnerable application. So once you click on this, here you see all the folders and the file that is there within the /data/application folder. Okay, so you can simply click on this. If it contains any file, it's shows over here. So if there is a database, then you can simply click on any of the database file. Okay, it contains nothing. But if it contains any data, you see, it will dump all the tables information along with the columns and rows within this particular interface. And if you want to see a logcat, you can simply click on this. You will see live logcat of that particular device. So this is how this particular tool works. Now let's try to bypass the root detection checks using this the step that I mentioned. So the first step, we have to do the reverse changing of that APK. So when we click on this, okay, so let me open this. So this is my tool. So it will basically download this into. So I'll just walk you through this. So there is so once you download this Android Application Analyzer, which contains a apps folder, okay, and when you click on this APK tool, it's try to decompile. It's try to first fetch the APK from the device and then try to decompile. Okay. So I have to select the application that I want to bypass the root detection checks, and that is com.nss.notsosecure, not so simple Android app. And let's do Apk tool. So it's doing stuff in the background. So let's just wait for that. So once done, you will find a tool that is there within the apps folder, which basically created as output of Apk tool -d option. So in order to bypass this, I usually use a string-based comparison within the whole source code. So let's just try to search for that particular error message and restart the emulator. Meanwhile, those who are doing a hands-on during this workshop can simply download all the source code. Okay, it just loaded up. Okay, so let's just search for that particular string, and okay, and this is the folder path where I want to search for this particular string, and that is the Android application analyzer apps, and this is the package name. So let's just find that. So you see there are so many occurrences for the rooted, but if you search for the complete string, you will often find that into. So you'll identify that within this particular source code, and that is not so simple Android app validation root checker.smally. Okay, so let's just go to that particular folder. So it's within smally, com, then NSS, not so simple Android app. Then there is a validation, and it's inside a root checker. So you see, you have identified this at 3 places at line number 143, 164, and 190. So the first error message is over here. Okay, and if you open that into a JDG UI, you have to click on this particular button. It will use in the backend. It will use the dex to jar and convert the APK file into a jar file. So this is the function. The first one is the check magisk and exposed. Okay, and you see this is the error message that is shown or that is popped up, and below, exactly above, there is a if condition. So what if we tweak this if condition? Okay, so what I'll do, I'll just replace this EQZ with the NEZ. So EQZ, that means it will check the equality in the Smally code, where NEZ, it will check for the not equality. So we'll just tweak the condition. So if it identify, then please do nothing. And similarly, we'll do it all the 3 places. Let's save this. Okay, so now we have to perform so many tasks as I mentioned earlier, and that is we have to use Apk Tools, then sign APK file, uninstall, and all these stuffs. So that's that thing you can simply achieve it using while clicking on this particular button. Let's say reinstall it. So in the background, it will recompile the APK file and just try to sign this APK, and then uninstall the older one and install the newer one. So let's just wait for some time. It's just doing some stuff in background. So now it's done. So now let's try to open that. So you see, we have successfully bypassed the root detection check using the Smally code modification. And now it's showing me an error. It says that application running on emulator. That means it has implemented this particular stuff. So now let's try to bypass the root detection check using the frida. So before diving into the frida, let's first understand what is frida is. So the frida is dynamic instrumentation toolkit, which is used by the developer or the security researcher or the reverse engineer to hook a process into to hook a function or the processes within the process environment. Okay, so let's move on to the installation stuff. So in order to play with frida, you have to install the frida client and frida server, where you can install the frida client using pip install frida tools on any of the client OSs like Windows, Mac, and let's say Ubuntu or the Linux. Then you have to install the server version on the Android device, where you have to go to the frida release page, where you have to go to the server. You have to navigate to the frida server, where you have to download the Android the specific binary which is there for your device. So once you have downloaded, you have to push this server, the Frida server, into your Android device, and that is, I just for the timing, I just put that into a data local temp directory that is there within the Android device, and then you have to run the Frida server using /Frida server, and then run it into a background. So let's try to bypass this using Frida script. So once the Frida successfully installed, if you navigate to this particular command, frida-ps-u, you will find all the processes that is running on the Android device. So let's try to bypass this using Frida. Okay, so it's showing me the device is rooted. So in order to initialize the, so it's visible, right? So in order to initialize the Frida script, you have to use java.perform. So once you have done that, let me save this as in the tools. Let's say Frida BSides.js. So in order to hook the function, first we have to identify the class in which this particular function is there. So you have to navigate to this JDGUI, where you see there is a package called com.nss.the not so simple Android app .validation, where there is a function called check magisk and expose Firebase root checker, and then there is a isRooted root beer. So these are the three functions that we have to hook and modify the function behavior. Okay, so let's do it. So to do that, first we have to create an object. So it's obj, it's a root checker. So we can instantiate an object into a Frida script using java.use, where we have to specify the name of the class. So this is there within this particular package. So let me paste this. Acha. Okay, better to use word wrap. Okay, done. So the name of the class is root checker. So we have created the object of that particular class. Now let's try to hook the function. So the function name is nothing but check magisk and exposed. So I want to modify the function behavior. So we have to use implementation is equal to function. Then let's say console.log bypassed magisk and exposed. So what I have done over here, so whenever this particular script is hooked into this particular application, so instead of calling this two statement, the if condition and the pop-up, it will show you this particular error message. So now it will not do any kind of validation. Okay, so let's override other two functions as well in order to bypass the root detection. So again, we have to use the object. Then we have to use the function that is Firebase root checker. And I want to and the third function name is obj root checker dot is rooted root beer dot implementation. I have to modify the function console dot log bypassed root beer check. So now let's hook this particular JavaScript into an Android application. So to do that, we have to use, okay, let me zoom a bit. Okay, so we have to use frida -u. Then we have to provide the package name, that is com.nss.notsosimple Android app. Then we have to specify the script that we have created, that is BSides shit. Then no pause. So that means whenever this function hooked, please don't stop. Please continue the execution. So when I run this, okay. Okay. So in order to do that, first we have to run the server on the Android device. So let me quickly do Adb Shell, where I have putted the frida server on data local temp folder. So you see there is a frida server is there. Let's just run into a background, and now let's try to run our app. So once everything goes correct, you see it hooked all these three functions, which says that bypass root beer check, firebase check, and the magisk and exposed. And you see this time it will not show me an error of the application is running on the routed device, but it's showing me an error of application running on emulator. So let's try to bypass this. As we all know that how the application implemented the emulator check. So when once you search for this particular string, you landed up this particular class, and that is integrity check, the emulator checker. So let's just create an object of that particular class into our script. So let's say where, and let's say emulator is equal to java.use, and let's try to bypass, let's try to modify the function behavior. So to do a checking, it has a function that is emulator. So let's just modify the function definition for this, and its implementation is equal to function console.log. So instead of do all these checks, please do nothing. Please print an error message for me. Let's say bypassed emulator check. So this is the function that I overwrite. Okay. So now let's try to run this script. Exit this one, and please run the modified script. So you see the emulator check, the emulator detection function is successfully hooked, and we are successfully able to bypass the emulator detection as well. So now it's showing me an error of application integrity is tampered. So as we haven't modified anything, but for the purpose of this workshop, I'll just mention the wrong checksum into while creating the Android application. So in order to show you how we can bypass this, okay. So let's so based on the string search, you will find this particular error message within this particular class, that is integrity checker, and there is a function called check for app integrity, which is responsible to do this particular stuff, where it uses the zip file function, and over here it just match the cyclic redundancy check, particularly checksum. Okay. So it just read the existing from this particular string ID. So let's just try to bypass this. So to do that, let's create integrity object, java.use. we have to select the path, and that is com.nss.notsosimple Android app dot validation dot the name of the class, that is integrity checker, and the function name is check for app integrity dot implementation is equal to function So once this function successfully hooked, please do nothing and please print a message app integrity check. So now let's try to run the modified script. So please close the existing one and run the modified script. So we are getting some error. Okay, there is a typo, I guess. Oh, I just used the wrong class because it's obj integrity, and I just used the emulator one. So it's showing me an error. This particular function is undefined. So please use the correct class. So we have successfully bypassed all the checks. Now we are able to access the application. And if we click on next, it show me it will landed me to the next activity. So what we have to do the API analysis, first we have to do a proxy configuration. So when we do a proxy configuration, let's just do that. And let me quickly identify my IP address. Okay, 172.20.10.2. So now, if you run this particular script, in order to capture the traffic, you see, now it's showing me an error that network proxy is detected. And when you see the bub log, you see, it show me the event log, which state that, okay, let me open this into a bigger window. Okay, just a minute. So the first error message said that the client failed to negotiate a TLS connection to this particular endpoints. So what generally a pen tester do? They use a open source script, and the heaven for us is the universal frida SSL unpinning script. Okay, so let me show you that as well. Universal SSL unpinning frida. Okay, let me search for GitHub. So there are so many open source script is available. Yeah, but I already copied that, so let me show you that as well. So this is the universal frida SSL unpinning app, where if you want to bypass the SSL pinning, then you have to first drop your CA certificate within this particular directory. So I already done that. So if you go to that particular directory within the tool, you see there is already I place this particular script. Okay. And then you have to run the script. But this is only for the SSL unpinning. What about the all other three checks? So we have to club our existing script, this one, and the universal SSL unpinning script. So that I already done. Over here, I've just created 3 objects, which basically allow me to bypass the root detection, integrity, and the emulator detection. And there are function implementation that is there. Next to this particular object creation. Okay, so let's try to bypass this using universal script. So you see, it just bypassed, it just hooked this particular function, trust manager implementation. But if you navigate to the application, it's still showing you an error which said that the network proxy detected. Okay, so you will often find this kind of an error if the developer is implemented a custom function. Okay, and using this particular script, you will not able to bypass this particular SSL pinning check. So over here, there is no dead end. You have to just analyze the source code. You have to identify the function which is responsible to do a SSL pinning check, okay? And then you have to hook that particular function. So let's do that. So let me get back to my original function. And if you navigate to this particular class, pinning checker, where I use the OKHTTP3 and just create some threads and stuffs to do SSL pinning checks, where this is run function is basically responsible to do a checking within the pinning checker. Okay, so let's just create object of that particular stuff, where obj pinning checker. And the name of the class is this. And sorry, name of the package is this, and the name of the class is this. And now let's try to overload the function, and that is obj integrity dot run dot implementation function okay. So now let's run this particular script. Exit. Please run the BSides21.js in order to bypass all this stuff. Again, there is an error. Same, it's undefined. Okay, again I did the same mistake. Exit and run the new one. So you see now it has bypassed all this stuff. And if you navigate to the application, now you are able to access the application and to do a pen testing further. So the most common question I was asked when I do or when I present these things, what if the source code is obfuscated? What we can do in that case? Okay. So in that case, the approach is same. You have to do a string-based comparison search, and you have to identify the class, and you have to identify the function, and you have to bypass all these checks. So I also created the vulnerable application if you want to play with that. So let me show you that as well. It's inside APK obfuscated code. Now let's just uninstall the older one. And install the obfuscated one. So the functionality is same. It has implemented all these checks, but when you do a JDGUI, in order to understand the source code, let's just reload it and select the application. And when you do a JDGUI, you will see now there is no package that is called validation. However, I already created, this is the same code, but just I have implemented a ProGuard within this particular application. So there is no folder called validation, and there is no class that is there, like we have previously, root checker and the integrity checker and so on. Okay. So what you can do, simply again, you can download the source code using Apk tool. So it's not useful for the download. It just extract the APK from the device and perform the reverse engineering on that. So once all done, so you see there is obfuscated code. Now there is no classes within this particular folder. Okay, now let's just search for that particular string. The device is rooted. Okay, so now it's within the gw.smalley. It's not inside any package, it's just within the root folder. So this is there. So yeah, I accept that it just takes so much time in order to identify the function in case of obfuscated binaries. Okay, and that is GW. So you will find that. So now there is the function is not a well-known function. You see there is a, then there is a C, then there is a D. So all the function name is also obfuscated, even the variable name also. But the most interesting thing is the error message remains same. So based on that, you can identify the function or just track the function that is used to call that particular thing. So again, you can write the script for that. So to save the time, let me show you that. I already created that particular script, and let me explain this and then run this particular script. Okay. So here, instead of using a package structure, what I'll do, I'll just use the direct class name because it's there within the root directory. So GW class is used to do a root checking, HF class is used to do a emulator checking, EL class is used to do an integrity check, then this. Okay. So here the implementation is bit different than the other. So you see, using this particular code base, we are trying to implement, we are trying to modify the function behavior in the older script, but over here we have used the old overload. Again, overload is the concept of object-oriented programming, okay, where there are two functions which has a different number of argument, or let's say different data types with the same arguments. So this is useful when there are, so when the obfuscation is performed, you will identify there are multiple functions with the name or with the same name. So, okay, so in that case, you have to use the overload, otherwise it will not work. It will throw you an error. So this is why I have used the overload. So to do a check, let's just run that. It's obfuscate.js. So all the function is hooked, and we are successfully bypassed all the checks, even in case of obfuscated code, and we are able to access the application. So with that, we have successfully analyzed the APK file. We have successfully bypassed all the checks. Now what to do? So now we are able to do a real pen test. We are able to find the esoteric vulnerabilities, which are generally untouched vulnerability due to these checks that is implemented within the application. Okay. So let me go to the presentation. So we have successfully bypassed all these checks. Now let's jump to the esoteric vulnerability. So this particular portion is taken by Sharan. So Sharan, over to you. So for me, if you are implementing anything at the client end, then a developer is capable to bypass this at the client end. So you have to do most of the checking at the server side. Otherwise, you are not protected.
Okay, got it.
And these all are the, let's say, enhanced security bugs. It's not kind of a bug, but it just makes for the pen tester bit difficult to identify the further vulnerabilities.
Okay, so we have to do all the checking on the server side, right?
Yes.
Using the APIs.
Most of the cases.
Okay, got it. Thank
So
you.
these all checks cannot be implemented on the server side, but these are the enhanced security which makes the pen tester difficult to find the other vulnerabilities. Because if the pen tester is not able to bypass these particular checks, then he or she is not able to do a pen testing further in your application.
And you have written that JS file to bypass the functions, right?
Yes.
What if I do change in the Java file itself and rebuild the APK and then install?
Sorry?
You have written that JS file, right? To
Yeah.
bypass the function. What if I directly change the source code
Yeah.
of the Java file itself?
Yeah, but you do not have access to the Java file directly. So if you decompile the application, you will get output of Smalley code, and Smalley code is bit difficult to understand. Okay.
we seen that, right?
Yeah,
Function,
that
it is,
that's we have seen in the JDGUI. But if you download all the source code, then you are unable to make an APK file out of it.
okay, understood. So
Yeah.
JDGI is providing the view, right?
Yeah, it's providing a view that is
Okay.
there. So there are so many third parties packages is there to build the APK file, right? And that is generally not shown in the JDGUI, or it's generally cannot be, we cannot use that source to rebuild the application.
Okay, and while signing the APK, we are doing zip align, right?
No, I'm just using the sign.jar. So basically, jar signer it uses in the backend. So it basically sign the application using the test certificates.
Thank you.
Yeah, thanks.
So I hope you understand how we can modify Android application. Yeah, or we can take question at last. So Sanjay has explained us that how we can modify Android application, the small code. If it is a client-side code, right? So I can trace the source code and I can modify the things. I can bypass. So those things are explained using a frida. Now we will move ahead. What after bypass application using some functionality, right? If Android application, if you are there, it has activities. So we are looking at esoteric vulnerabilities like Webview. Everyone knows Android application uses a Webview. Then remote debugging of Webview, Webview interfaces. What are these things? Deep links. What are the app links? File picker, misconfiguration, and mobile passcode or 2FA. How we can bypass it using a bash. So everyone knows what is a web view, right? In Android application, if I want to load some website, a developer want to load some advertisement, or he want to integrate some third-party application, he don't want to develop an app, he'll just add a web application inside the Android application. As you can see in the screen, a google.com is open, which is actually a web view app. It's loading a web HTML content inside the application. So what WebView allows you to display a content part of an activity layout, which is an Android activity. Third-party application integration. Suppose I want to do a PayPal payment on my Android application, and I just want to do integrate a PayPal inside my application. So I'll just use a WebView, and I'll call URL paypal.com. Advertisement and native app extensions like React.js, most of them they use a WebView. So if Webview is going to use, there should be a way that we can identify as an attacker, we should know how application is using a Webview. So how to detect a Webview? So as everyone knows how we reverse the application using ZX or using small code, if you do a ZX that gives a Java, that is very simple to understand. And if you see there is an import for anything I want to initialize in Java, I should import the class, that the Webview is a class. So when you reverse the application, first check Webview is there or not, and there is a setting for Webview that is always there. So it has, if you see the setting, it has Webview client over here, then and interface is there, my interface, and it has a load URL, which loads the URL if capital URL as a parameter at extras. So extras are the intent which is used by Android application. If I want to pass something data to another intent, so I'll pass it as extras, or I can pass it as a query parameter. So this is my vulnerable application Webview, which I defined here. So let me quickly show you how Webview actually works. So this is my Android application. Hope everyone is visible for this. So if I open a URL inside my Webview, notsosecure.com. So as you guys can see it, this is a web URL is getting loaded into my application. This is an Android application. This is not a browser. So I can see, and there is no way as a victim. I don't know what is the address bar over here, and just I'm surfing a web application. And imagine if attacker is able to load his own URL inside the application. So that will make a big phishing attack, or he can steal the cookies as well if it is access. So most common vulnerabilities in WebView are, first one, you should have an exported WebView. Without exported thing, you cannot exploit anything in Android. Then, what are the JavaScript interface which are used in WebView? I'll explain it later. Universal file access. Suppose if you have access to some particular function in WebView, then you can access internal files of an Android application which are only restricted to that application. That also can be accessible. Cross-site scripting, which will act as a universal access on that Android application. So if you are able to achieve access on that particular WebView, you can perform a universal access, means you will have access of all the application. Then content providers, sometimes Webview can be used to exploit the content providers. So let me quickly show you this code. If you guys see this code, this is my vulnerable code. So I have a web view over here. It is exported and takes a capital URL parameter. If you observe here, it takes as a extras. And I want to exploit this as an attacker. I know it is taking as extra parameter. So if you observe this here, Adb Shell. So I'll explain what is Adb. Adb is an Android debug bridge. It acts as a bridge between mobile application and my terminal, so I can perform some action. So Android provided that to everyone for testing and debugging process. So Adb, Android debug bridge, shell, then AM is activity manager. So I want to start some activities in Android application. So I'll use Adb Shell AM start. And if you observe over here, this will be a package name, which is in this case my vulnerable application package name. Which is com.example.webview. If you want to see it over here, I can show it to you guys. So this is my package name. This is the source code of vulnerable application inside the Android Studio. And this is the Webview activity, which is actually I'm going to, I have declared in my Android manifest file, and you guys can see it over here. So this is browsable. Browsable means it is, I cannot zoom. I think it's visible, right? Yeah. So this is a browsable, and any exported activity can be opened using Adb Shell AM start. And we can pass extra capital URL because all we have seen that it is accepting a URL. So let's just quickly open https://bing.com using our Adb Shell. Let me just copy this, paste it over it here. And as you guys can see it, Adb opened my web view and an extra parameter of bing.com, which is loaded over into my vulnerable Android application. So won't you think it's very easy that we just have passed extra parameter URL and it is going to get open. So imagine if attacker is able to open this URL remotely. So, so how that will happen? So the question is how we can achieve this vulnerability remotely. Because I am doing it in the Adb, so any local Android application can exploit this. But as an attacker, I'll always try to increase the impact. So for that, there is a beautiful concept which Android has implemented, which is the deep links. So what are the deep links? Deep links is nothing but I'll just explain simple. Suppose you are surfing a facebook.com and you find your friend's profile like facebook.com/sharan.paniga. And if I click on that URL, Facebook app will get open with that profile directly. So that's a deep link that it will navigate to you from HTML to your web application with whatever the content which is provided and what are the process defined. So deep links are nothing but it will help user to navigate between web and application. They are basically URL. Which navigate user directly to specific content in the Android application. So this is a structure of deep link. It starts with first Android scheme. Scheme is nothing but HTTP, HTTPS, or anything you can put, a lol, you can put a Sharan, whatever name, that can be a scheme. So there is no limitation over that. Then there is Android host. Android host is nothing but www.example.com website, your URL, your domain that you can do, then the path. So if www.notsecure.com/ whatever the path directory is there, I want to open something, so that you can give as a path prefix or path pattern or path. So if you see this example, and if you want to form the deep link, the first one will form nss://openmyapp.com. So this will act as a scheme. This will act as a host. Okay. The second one, if you see it, HTTPS www.nss.com, and third one will be nss.com. So this is an Android manifest file. You have to go to Android manifest file, intent filter, and you have to form a deep links. So how deep links works? I'll just quickly show you in our Android manifest file. So this is my vulnerable application. A webview activity is here. So I have defined the scheme https://www.sharan.com, and second one is lol:/lol. So both these deep links will open my application because the intent filter here, it is a browsable. So whenever you get a browsable intent filter, it is by default exported, and you guys can open that using a deep link. So let's quickly I'll show you how deep links can be opened using Adb and remotely using HTML. The simplest one is how we can open a deep link using Adb. So we have to use this intent, which is a view intent. hyphen D is a URL that we have to give. So I will give lol:/lol. So this is not a URL, this is just a deep link. Lol is my scheme and lol is my host. And this is my activity name, package name. So I'll just simply copy over it here. So as you guys can see it, as I opened that view, my web view got opened, but nothing has happened because I haven't provided extra parameter over here. So what if I can I open it through HTML remotely? So let me quickly show you that. I have already lol.html with me. So if you guys can see it over here, it's same deep link, which is a href. So it's a URL lol:/lol. So I'll just host it on my local server, and let's try to open it over here. So I'm going to Google Chrome, not in my WebView application. So I'll just close it. So I'm currently, imagine I'm surfing something on my Facebook, and I got this website. Okay. So lol.html I need to open, right? I'll click on lol.html, which says click here to open. So I'm surfing something on internet. If I click over here, as you guys can see it, as soon as I click over it, it got opened my WebView application. So that's the way you guys can attack it remotely. You have to form a deep link and provide to a victim. If victim clicks on that, Android application will get open. Now the question is, I can open the application remotely. Now the main thing remains over here, the extra parameter -URL. I cannot pass extras through HTML. There is no way, because HTML doesn't work in that way that I can directly pass extra parameter to the internet. For that, Google Chrome come with a beautiful concept, which is Chrome intents. So whichever application have a Google Chrome, they will support this Chrome intent. What is Chrome intent? That is briefly given in developer.chrome.com. You can study it. So what Chrome intent do, as a HTML, you guys can literally pass a package name over here through HTML. You can pass action, category, component, scheme. So all these things can be possible, can be passed through a HTML using this deep link. This is the structure of Chrome intent. Sorry. So if you see this S capital or Ssr, this is act as extras inside the intent. So if I want to pass something extra, I'll do s.capital URL. So how to form a deep link using Android Chrome intents? This is here as example. So it will start with intent. Okay. So you guys can see it over here, intent. Then ://. Then there is a URI or a host. So my host is, if you remember, it's a lol. So I added a lol over here. Then we have to pass a hash. Hash, again intent and semicolon. Then we have to provide what I want to do as an exploit. So scheme is again lol, which I already shown you. Then package name. So I can literally provide a package name to open this package, com.example.webview. And here s.capital URL. So I'm also able to pass extras, which is actually a term intent that cannot easily pass, that are only allowed to pass in the Android application. So let's try to open this using an HTML. So I already intent.html. So if you guys can see it over here, it's similar, intent : / lol intent, then activity name, and extra parameters. It's opens on not-so-secure.com. So let me quickly host this on my local server and see how this happens. So I'm on a Google Chrome. Okay. So this time I'm clicking on intent.html. Now, if I click as a stranger, if I click on this, as you guys can see it, not-so-secure.com is actually open in the application of my vulnerable application. And as a victim, I have no idea what I'm surfing. I don't know it's a not-so-secure.com. I don't know it's a victim attacker website or nothing. So there is no way. There is no address bar in the WebView. That's a drawback of WebView. There is no address bar. So that's where you can exploit exported WebView activity. And trust me, every activity a WebView takes a URL as an input parameter, because end of the day it has to load the URL. So as an attacker, you guys have to find that entry point, that where it is taking the URL, and if it is exported, you guys can report this vulnerability. This will be a high vulnerability, and you will get a good reward of this. This is the extras we have seen, and this way you can, if deep link is there, you can exploit any deep link which is supporting extras, or any other vulnerabilities also can be exploited if it is using a deep link. Through extra query parameter, sometime Android also uses a query parameter if URL contains some queries like parameter. So you can also pass it through question, like as a parameter capital URL. It will work if Android application using not as extra, as a query parameter. So most common deep links are maintained here with one of, I don't know who's this, but he had given very good how you can check all the deep links. So if you click on test, at the bottom you can see it. I don't know if you can see it or not. You just go to this Android app linking, you will search it, and you can test all the deep links, and you can learn all the deep links over here. I have also written one small Android deep link parser, which will, I think, soonly get merged with MobSF. I have raised the parse request. So what we have to just give a Python 3 deep link parser installed APK. If I provide an input it to you, it will list out all the deep links which are available on the Android application into a terminal, and you can access and you can play with those. So I'll explain. So you can see the output over here. These are all the deep links which Instagram supports. So I'll give a demo ahead also, and you can just see it over. So this is about a web view. Now you guys will say that's very easy, right? If I got a URL, I'll just load it and I'll exploit it. So that's not a case every time happens. What developer does, he knows that URL is getting loading at the end of the day. So what I'll do a host validation. So if I am a notsecure.com, I'll strictly whitelist my notsecure.com should only get open inside the web view, and no other sites will allow it. So that is a security implication. So I found a similar thing. Okay. So before that, I want to mention this. This is not a report 431002. You guys can note it. This is a big. I want to thank like Baggy Bro. Everyone knows it. He's a great hacker. He's a great inspiration for me also. He's a great hacker. You can learn a lot of using his tools. So he had given us a golden techniques to bypass host validation. How we can pass a host name validation. You can read this. 431002. Go through it, and I'll just explain two of them over in our talk. So there is a problem with /trick, the first one. So if you guys observe it here, attacker.com, if I add a / and @legitimate.com. So if you see it here, so when he passes the URI in Android application, it prints legitimate.com. He actually tried it, and when Webview get loaded it shows attacker.com. So whenever Webview gets loading, the legitimate.com will not get loaded at attacker.com. In that way also you can bypass host validation. So how that can happen? So using href, you just have to pass this URL. So this will load attacker.com, and using our Chrome intent also, you can pass this. So that was a second thing. Now what is a scheme validation? Scheme is the first point, which is lol, which is in this case is a JavaScript. Okay, so if that is fails, how you can bypass that? So this is a simple payload. Everyone knows if everyone do access. This is a default payload you guys can use. I have just added over here legitimate.com and %0a. This is nothing but a /n that will entered, and alert will printed on the next part. Let me just quickly copy and show it to you guys what this actually do. Okay, so if I do a JavaScript :legitimate.com alert, it says alert 1. Okay, now what I'll do, I'll just modify the host of it. So I'll put anything like lol.com. So still it gives me alert 1. So you guys can understand there is a hint that you guys can mention any host or anything over there, and that trick we can use to bypass our host validation. So how that worked in one of my Flipkart older application, how this bug was present there, I'll just quickly show you. So this was the source code which is using Webview activity by a Flipkart older version. This is patched one. This is not just for demonstration purpose. I'll show you. So you can see it, small URL is there, a capital, which is taking by a Webview as an input. I identified this using a source code. And let's try to quickly open that using Adb. That will be a quicker way. And I have already installed a Flipkart app inside my application. Okay, so if I paste it over it here, so I'll just show you. Nothing has happened. Nothing has happened. So URL parameter is there, but it's not taking anything, and Flipkart app also is not got open. So if you guys see it here, nothing has happened. So it means that it is exported, but it's not taking my input, which is a bing.com. It means it has some validation. Okay. So let's try to go further in the source code. I analyze further, and if you guys see it, if it starts with FK Seller app. So that's a scheme which is used by Flipkart, which is FK Seller app. And if it starts with this, then load the URL. And else if, they also provided else if it won't start with also, you can load the URL. So that's a hint that it doesn't verifying the scheme which starts with FK Seller app. So we can provide any scheme to it. So let quickly dump, let me show you how Android Deep Link Parser works. Just go to Android Deep Link Parser, Python 3. Deep Link Parser and flipkart.apk. So this is a tool which is available on my GitHub repository, and soonly I think it will be available in Mobis if they approve my merge request. So this will decompile the code. It will parse the Android manifest file and string.xml, Android manifest.xml, which contains all the deep link, and sometimes string string parameter or string value is given, that is also passed. And by collecting all the inputs, it will form all the deep links. So as you guys can see here, these all are the deep links which are available in the Flipkart app, and you can call, suppose if you want to call a main activity, it supports plenty of deep links. And in this case, I have to show you for the Webview activity, which we are exploiting over here. So this is a Webview activity, and it shows that I can open a Webview activity using 3 deep links. First one is, if you can see it over seller.flipkart.com/terms of use, then privacy policy, and last one is a URL, which is a learning center URL. So if I found a 3 deep link, now how we can exploit the Flipkart. So if you observe clearly over here, first it's a scheme, and second, if you observe seller.flipkart.com, in all 3 deep link, the host, the domain is common, which is seller.flipkart.com, and I got a sense that it might verifying it requires a seller.flipkart.com. So what we'll do, as we already seen in the source code, it is not verifying a scheme, so I'll just put a lol over here, and I'll do a test.com. Okay, let's see it. It's just a trial and error. Let's see what happens. As every attacker, we do a trial and error. So nothing has happened. Application is not loaded. So scheme is not available. I tried a test.com, it not work. Let's try lol:/seller.flipkart.com, which is a domain which is used by application. So I'll just copy it and paste it over here. So as you can see it, as soon as I paste it over it here as a deep link, it opened Flipkart app. So lol:/seller.flipkart.com, a domain verification is there. So it is verifying that a domain should be same and it should not be anything. So that was the part. So how we can bypass, I already shown you the JavaScript, which is can be used. So if you see it over here, a JavaScript can be added, and I already shown you that we can put anything over here. We can put anything over here. So I put it a seller.flipkart.com, which actually application required, and I'll just copy. I just added a alert 1, 2, 3, 4, 5. You got the accesses. And this is a universal accesses, like Flipkart application. I can access it. I can access any component of the application because this is the actual web view which runs Flipkart application. This is patched one, so don't try it on the newer one. You can go older one, you can try that. And I already given it on our GitHub. So that's way you can bypass the Flipkart one. And for this, they have rewarded me some work. This was a medium level vulnerability. I was not able to exploit it remotely because the deep link is not a browsable. That was not a browsable. I don't know how they patched it. So that one was there, web view. We'll see universal file access. So this was a setting which was introduced by Android to bypass origin check. So if I have a file and if I want to access another file scheme, like file scheme etc passwd, and if I want to access through some other file, that is not possible, right? That is not possible because SOP will not allow us to do that. But for that, what Android had given API level before 30, they have given this particular check, set allow universal access file from URL. If you access this, it allows, there is no origin verification. So file colon sharan.com can access internal files. So that is allowed. So if this check is enabled inside a web view, sometimes developer do it. It is deprecated, not allowed to, you cannot be used after 31 also. So Android 10, 8, 7 are vulnerable if this setting is allowed. So how to exploit this? This will be a simple XSR you have to do. So what you have to do over here, you have to create an exploit inside the SD card. So SD card is accessible to every application. So file colon / SD card / exploit.html that can be accessed by you as an attacker, you can access it, or browser also can access it. Okay. So you have to create this exploit. This is a simple XSR request. Whenever you have XSR request in the world, this is a simple one. So what we have done in the URL, what we have given, an internal path of the vulnerable application, which is a WebView application. You can see it /data com.example.webview /cookies. The cookies is my internal path. So whenever if you want to exploit this, so you just have to do the same thing. Instead of URL, you just have to pass exploit.html. For that, you need to put exploit. There should be other ways how we can put that you have to find a way how we can put exploit in SD card. So once you put exploit in SD card, if you call that SD card using our remote attack or Adb Shell or whatever you can do using a deep link, you can actually access the internal directories of the application, and internal directories are only accessible to that application. If I have a WebView application, my internal files will be accessible to me only. No other application can access my files. That's how Android works. Only sudo user, I think, can access all the files. So that was about universal file access. Let's look at remote debugging of Inverview. So as a pen tester, if you observed the application which runs as a native app, and you want to, find or you want to analyze, the what going inside the application. For example, native app is using a web application, but you don't know what it is actually. So if you want to debug, or if you want to understand what are the network traffic, what are the DOM elements are using, Chrome has given a remote debugging for a browser, you can say, for that. So this will allow you to debug a live content, Android devices from Windows, Mac and Linux computer, inspect and debug a live content of Android and DOM manipulation. So let me quickly show you what it is. So if I go to a Flipkart app again, so this is an application, okay, Flipkart. And if I click on a register new account, how many of you will say this is a web application? So this can be Android application or this can be web application, right? So as a pen tester, your job is to verify. So there is, that already explained that we just have to do a age // inspect. In Chrome, you can do a Chrome // inspect. I'm using age over here. So this will inspect the devices which is available in the network. For that, USB debugging should be enabled on your application as a penetration tester. And if you see it over here, seller.flipkart.com is got opened. So indirectly, Flipkart is in the backend, is using a web application. And if I click on the inspect, you guys can see it. So in the Chrome browser, I'm able to access all the DOM element, all the application, all the traffic. And if I do a alert over here, this will be comes. So you can communicate. So I guess you will guess that what is the advantage of this. So you can actually access the DOM element. You can check what are the DOM best content, DOM accesses, kind of vulnerability, which are sometimes you will fail to identify SSL pinning. That you can just go to a network tab and check all the request and response of the Android application, which is using a web view. So native app, whatever the native app, React.js app are usable. And if you fail to do something, you can go remote debugging and you can access everything of that application. So that's the beauty of remote debugging. And in day-to-day job as a penetration tester, I use this very often. So that's about remote debugging. Now, the most important concept comes JavaScript interface. So I like this concept very much. I'll explain why I like it. So I have a HTML page, and I want to provide some input to Android application. Like click on this button and go into Android application, do something. So that's amazing, right? From HTML, I can control Android application. That is a JavaScript interface, which is implemented by Android user for convenience. So if I am on HTML, And if I want to perform some action in Android application, I can do using a JavaScript interface. And suppose I want to return some data from Android. So I want to do a handshake of local cookies, and I want to refresh them sometime. So I want to access it through local, and I want to pass it through my web application, suppose, to show something, some data, some content, which is passed in the local. So JavaScript interface is a key concept that can be used that communicates between mobile and HTML or JavaScript, you can say. So that is about JavaScript interface. So I'll just quickly show you what is the interface. So this is just a little JavaScript that will help you to understand. I want to explain it. So in JavaScript interface is defined inside the Webview only, because it's end of the day it's a HTML, so we need a Webview. So we to define a JavaScript, you have to add a Webview dot add JavaScript interface, and you have to provide a interface name, which is in this case is a my interface. So you just have to check the my interface, and this is a function. So whenever my interface is a web view, and whenever show toast function get called, it will show something. So toast is an Android application which shows the message in the Android application. So this is the Android part. So if I want to show, if I want to access it using HTML, I just have to create an HTML show Android test, and I will pass the input hello Android over here. And as you can see it, I am calling my interface, which is my JavaScript interface, and I'm calling a show toast function, which is actually inside an Android application. This is not a JavaScript, or this is not a HTML function, which is an inside function. And if I do a toast, whatever message I'm sending, it will be sent to Android application. So let me quickly show you how that works. So if I click on a say hello, so you guys can see it, say hello is there. So if I click on a say hello, it says hello Android. That's a toast. If you see a bottom, there is a hello Android. So that comes from an Android, and I'm on a web application. This is a web application. I'm clicking on a button, and I'm actually calling an Android application function. So that's a web interface, and application uses a web interface for a lot of stuff because they want to communicate with their JavaScript function and everything. So how we can, as an attacker, exploit this? So for this, you need only one vulnerability. You need to open your URL inside the web view. Once you have open your URL into web view, the interface will be exposed to every URL which gets open in the web view. So that's the disadvantage of JavaScript interface. Even Google, if you go to Google Help, they have also said that they have provided two options to you guys that ensure that the web view do not add objects as a JavaScript interface. And second one, ensure that the web view do not load untrusted web content, which I am saying that, so this. So these are the interfaces. Let me quickly show you the interfaces over here in my Android application. So get user, get serial, get model, get product, which I have defined an interface in my vulnerable application. So you guys can see it over here. All these are get model, so it will just return a model inside whatever the model is there. This is only accessible to Android, not HTML. What is the user? And lastly, I have given a get authentication token, just authentication token, which is inside my Android application. As an attacker, how to list these interfaces? So we can list these interfaces using remote debugging. So we have to do again inspect, and we just have to go over here, as you can see it over here. I just have to call this object get own properties window. So this is just a common property. If you click on here, you'll get the all objects which are available in the web view. And here is our objects are also available, like my interface. Okay. Now if I want to access my interface data, I'll just add a window.myInterface, and I'll just go to my console. So you guys can see it over here. There are 5 components which are exported, and as an attacker, if I am able to load the URL inside a web view, I can access all these: get auth, get brand, and get model, get product. Let me quickly show you my interface dot get auth, and if I just call this function. So imagine I'm in a console, I'm calling a function. So it is returning a session token. Okay, so remotely how we can exploit this? So for that also we just have to create a simple XHR request. Let me quickly show you. So again, it's XHR request. So we just have to create XHR request, okay, and ask it to send to our collaborator, and we just have to call the function or object interface name and the function name which I want a data. So here you can see my interface.getAuth, that will be send data to a data, and that will send to my server. So let me quickly show you demo of this. Okay, so I'll just open a my listener post bin. You guys know what is a post bin. We can use a Burp collaborator also. So I'll just create a bin over here. Let me copy a bin inside my interface.html. So already there is a script. I'll just add XSR request over here. Okay, so whatever the my interface data you will get, just send it over to me. I'll just run a Python server. And I haven't implemented HTTP support in my Webview. That while I'll use ngrok to create HTTPS site for me, a public site. You guys know what is ngrok do. So it will tunnel my local interface to public using this URL. And if I open this URL on the internet, I'll get interface.html. So let's suppose attacker clicks on in his web view. He clicks on this URL, okay, and it got loaded into Webview. So I'll just simply open it over here. So as soon as I click on it, it will show me that simple shared website is open, and victim don't know what happened. And if you see our post bin, the token got leaked because the interface which we have added, there is no origin verification, there is nothing will happen. Whatever the URL victim gets loaded, that interface will be exposed to him. As it is exposed, he can access that interface and he can actually capture the token or any interface which is open. So that's the way you can exploit the web interface. So this was a vulnerability which I found in the bug bounty program. I cannot reveal the name of it. So this was a script I have created for it. It was returning data inside the function, which I converted into base64, and I forwarded that to my post bin. So what actually vulnerability was there? This is a chat application kind of thing. So if I insert a URL, it is sent to all the victims which have, and if someone clicks on the URL, it was got open into a web view. So, so what I did, as an attacker, I just added a URL through a web and as an account takeover name, and this is an ngrok URL. And when victim clicked on that URL, I got the authentication token of that victim because that web view was the interface which I was using by that application was exported, and I got the authentication token. And for this, I got for this vulnerability. So that's all about Webview and its vulnerabilities, which are that covered. So deep link versus app link. So we already seen what is deep link. It opens the Android application, right? So there is an issue with a deep link that a dialog, you might have seen it, that it prompts for the application, Maps, Google Chrome, like multiple applications support deep link, then multiple apps will open. If you try to open a Google Map URL, which is in this case, it provides me two options, a Chrome and Map. So that URL can be handled by two applications, that is Chrome as well as Google Map. Okay, so that is the issue with the deep link, and as I'm an owner of Facebook.com, and I don't want this ambiguous dialog. So if I open a Facebook.com, it should open a Facebook.com, right? Because this will be create a vulnerability. If someone clicks on any other application, so whatever the data that contains the URL, that will be passed to that application, right? So for that, app link is implemented by Android. So what app link is do, these are the differences. So deep link can be used HTTPS custom schema like lol we used, but app link is only HTTP validation. So whatever the HTTP URL comes, at least that should be verified. So what it does, if you guys can see it over a link verification. So none for deep link, and app link uses app link verification. So like big organization like Facebook, but they have to have the verification because everyone trusts the URLs. If Facebook.com comes, Facebook should open. So what you have to do, you guys also have an application, if you are a developer, you just have to create a .well-known asset link.json into your application. So I'll just show you the Facebook one, which is they have implemented. So you guys can see it over here. There is a SHA fingerprint, SHA-256 third fingerprint. So this is for every application they have created. And whenever a Facebook URL you are surfing on the internet, and if you click on, the Facebook verifies whatever your domain You have clicked it, and if it is matches to that domain, then only it open that Facebook application. So that gives a trust to everyone. So this is well-known asset link JSON can be implemented if you are passing password reset token by a URL. So many of application, if you get a password reset token, if I click on that, application code opens. So if as a victim, if I prompt 2-3 application, if I'm using a deep link, it will prompt 2-3 application. If I mistakenly click on something else, token will get passed. So that's why app link comes a big role over here. So deep links drawback are fulfilled by app links. So password reset pages, sign up, sign in verification, we can exploit this. So let me quickly show you simple exploit for this. There is what if attacker creates. Let me quickly open this www.sharanpanega.com inside my vulnerable app. So as you guys can see it over here, it prompted me 2 applications. One is my actual Webview, and second one is Chrome. So both can handle it. So let's try to create one more vulnerable application, which is nothing but an app link Sharpa. So what I'll do, I'll add a same deep link. The https www.sharan.com. Inside, this is a vulnerable app. And what I did here, whatever the intent data comes to you, just set text to URI, means set it over there. So this is my vulnerable application. I'll just run it over inside the Android application, and let's see what happens. So it's building a Gradle over here. It will take some time. Okay. So it got succeeded. This says hello world. That's a simple Android application, and you don't know what we have installed it. So now again I'll run my Sharan.com. So you guys can see it, there are 3 applications. By default it's showing as AppLink Sharpa, then Webview, and then Chrome. So 3 applications are supporting it now. So as an attacker, you can create your own. And by mistakenly, if I click on this, the Sharan.com got set over text. So for demonstration purpose, I'll just go to my Gmail. I've added a URL. So suppose if I received a password reset link of Sharan.com, and if I click over here, as you guys can see it here, the 3 apps are supporting it. I don't know which one to open. So that's a drawback of deep links. So that's why app links are given. And suppose I mistakenly click on attacker's app, the token at the end of C, it got linked to that application, and that can be used by that application, and that can be passed to. So that's the issue with the deep links, and app link is the most secured one. So Android 12 come with the new verification. If it is a HTTPS URL, it will first try to verify a app link. If app link is not exist, it will not prompt you this. It will directly open in a Google Chrome. So if you guys have these issues, you can upload it to Android 12. If you are using an older version, you are still vulnerable to deep link. So if you guys get any application which supports the older version than Android 12, you can report this vulnerability. And you will get a good bounty out of it. So that was the one vulnerability. Now let's look at for the next one. I already explained what is actually deep link, and this is the app link verification step. So package manager is there, then the intern filter. So it goes to well-known directory and checks in the cache that this fingerprint matches the fingerprint in the app link. And if it is vulnerable, that's where verification is done. Now, Android file picker. So how many of you share files on WhatsApp? Right. If you have some other application, like I have some Snapchat, I want to share a file from Snapchat. Snapchat also has its own file picker. So every application who want to share the file or receive file, it need a file picker. For example, if you see it over here, documents, photos, SD card, that are the file pickers. So anyone can create a own file pickers. And that can be used to share files internally through the application. So what are the vulnerability and what are the misconfiguration in Android file picker? Let me show you that to you. So what I'll do, I'll quickly explain file picker what it does. If I am a snapchat.com and I want to share some file, so that will share my internal path, data.com.snapchat.com/cookies/some folder or photos. It has some photos, so it will be on my internal structure, right? So if I want to share that folder, I'll simply share the internal path of the application. So that way, that's how file picker works. So as an attacker, what I did, I found this vulnerability in readable Chromium bug. I think I haven't provided reference over it, but I learned it from there. So what we have to do it here, we have to create the intent filter, which covers all the file pickers. So I added all the file pickers. For whichever application need a file picker, I'm available. So here is the intent filter of it, that you can use open document, a chooser is there, then pick is there, get content is there. So I have a created vulnerable application using this file picker. Let me quickly show you. That to you. Okay, so if you see Android manifest file, I have added every file picker intent filter over here. So whenever application needs, it shows so. And now the main comes part here. So if you see data com.google.android.app.docs. So this is a package name of Google Drive. Okay, this is not my application. So what I'm doing here, whenever Google Drive selects me as a file picker, I'll provide his internal path, a Google Drive's internal path. And let's see what happens. Will Google Drive will able to upload his own files into the application. So if you see it guys here, the path which I am giving here under Google Drive path, it is only accessible to Google Drive. Not even Google Chrome access the Google Drive folder or path inside the folder. That's how the permission are maintained in the Android application. So what I have to do, if I want to trick this to Google Drive, I have to ask Google Drive to click on my file picker. So let me quickly run this code for you, and I'll show you how file picker looks. So this will take some time. Till that time, I'll just show you Drive. And if I want to upload something over here, if I click on upload, so you guys can see multiple options are available. So if you have a Google Drive or if you have a Dropbox, Dropbox is also file picker. So as an attacker, if I'm a Dropbox or as I have created upload internal as an attacker, I just created that function. So it's running over here. So you guys can see application got opened and installed. So nothing has happened because I haven't given any code to her. So this is our upload scanner. Imagine this as a Dropbox as a application. So if I'm on a Google Drive, and imagine this drive URL is a shared URL, so anyone shared you a public URL, Google Drive URL, and you are going to upload something in that. And what you will do, you will just click on click on upload and upload internal, which is my vulnerable application. Imagine this as a Dropbox, and you are selecting some files over there. So if I click on this, you guys can see it. One file is being uploaded. He don't know what got uploaded. So as you guys can see it over here, this file is uploaded, which is a flag.obfuscated, which is actually a Google Drive file. This is actually a drive file. Let me quickly show you where it is. Adb Shell, I'll do a cd / the path which I have provided, data/data, then com.google.android.docs. Sorry, com.android.apps.docs. So this is an internal folder of Google Drive application, and we access a file which is inside cat flags application.xml. So you can see this is the same content which is uploaded over here. So Google Drive by mistakenly uploaded his own file, and if attacker have the access to this share folder, he can actually access, he can provide internal cookies, session of Google Drive, he can actually, get everything which is inside his internal domain. So that is a vulnerability available for the file picker. You guys can report this vulnerability. I recently reported this vulnerability to Edge, and for that they have provided me acknowledgement on their website. So Edge was a browser, so I have created HTML file upload similar to this. And when file upload was there, and when a victim clicks on that upload internal which I have shown, Edge internal cookies were get uploaded, and that are shared over to attacker.com. That I was demonstrated on Edge, and I got acknowledgement on that website. So you guys can use this vulnerability. So you guys will think what is a patch for this. So if I am a Google Drive and I want to upload something, I should verify my path. I should not upload my own file. So canonical path, a path which is going to upload, I should verify the path, the file which I am uploading or which I am sharing. It should not be your own files. So that is only a mitigation for this bug. That is also bypassable, but for meantime, I know only that mitigation. Now, we have, I think, 10 minutes. So the Android passcode, you should have to exploit it on that application. So internal paths are only accessible to that application. If I want to exploit a Google Drive need to click on that. So I'm uploading on Google Drive. I have provided the internal path of Google Drive. If I want to exploit a Google Chrome, I have to provide a path of Google Chrome, internal path of Google Chrome. So that's a limitation. There is a limitation with this bug. You have to firstly install that application in the victim, then user need interaction. So that's why if you see it, Google Edge haven't awarded me a bounty for this, because there is a huge user interaction actually needed. But this is a valid vulnerability, valid misconfiguration for a big auth like Facebook and this kind. Sometimes it happens because there is a lot of Trojan and everything happens. So this is a valid vulnerability, but impact is low, or you can say it's difficult to exploit. The next one is Android passcode. So everyone knows what are the passcode. If you are using a finance app, if you are using a banking application, there is a 2FA. So most of the time, rate limiting is there. Sometimes rate limiting is not there. This is a case of non-rate limiting applications. So if rate limiting is not present and you want to bypass a 2FA, how we can do that using a bash. So let me quickly show you how Android ADB is a magical to you guys. So you need to enable USB debugging, and there are some Android key events. Okay, so let me quickly show you one of the key events which Android supports. I'll just go to Google Chrome. Okay, I'll just click over here. So what I'll do, I'm just doing a Adb Shell input text Sharpa. You guys can see it over here. So as soon as So you guys can see it in the Android application, Sharpa got type. Okay, so we can provide an input to Android application using ADB. So this exploit, how it works, if I have access of any victim's mobile app, the 2FA works in that way only, because that is implemented for purpose that only if someone has your mobile, he should not have access to your application. So he can enable USB debugging. We can imagine that. He can enable that debugging option because he had access to your mobile. So he can, using ADB, I can type a Sharpa, and after that, I want to press enter, right? So there is a key events which are available in the Android application. So if I do a key event 66, which is for enter, so I am over here, and if I do a 66, it got pressed entered, and Sharpa got searched in Google Chrome. So we can use this trick to bypass a passcode. And our question is how? The simplest thing, you already might have got some guesses. So we just have to provide an input. If it is a 4-digit character, if I want to show you this, my vulnerable application has a passcode. So if I do 1, 2, 3, 4, and I have to press enter, this says invalid passcode. So I'm providing input, and I have to press enter. If I press enter, it shows invalid code. So I have to form this kind of structure. So what I'll do, I'll use a one-liner for a loop, which starts with 1 to, you can start with 999. I'm assuming this is a 4-character password. 1220, it starts with 1220, then up to 9. We just have to do a ADB shell, input our text, which is 1, 2, 3, 4. That as an attacker I have to give, and I have to do a key event, which is enter. So enter this and press enter this and press enter. We just have to loop this. So let me quickly show you how this will work and how this will look. Okay, you guys can see it. So it's starting brute forcing the application using ADB, and in this way you can bypass a 2FA. So that's a simple bash. You guys can use it. I have reported this vulnerability to multiple programs. I got a reward also. So this is a valid bug, and you can see it got bypassed on 1, 2, 3, 4. That was the code, and I got access to it. That was easy, right? So next one, I want to show you one more. What if it has a touch base? So I just show you input. Now it is not taking any input. It is a touch base. So it is difficult to exploit it, right? I cannot provide input. That's not easy to have a touchpad. So how, as an attacker, how you guys can imagine how to bypass this touchpad? So for that, Android have one more thing they have given us, that they have TAP tab. And if you guys can observe over here, Adb Shell Tab, let me quickly show you what is it. So if I'm over here, and if I copy this tab, okay. So if I press enter, it tap 1. So why tap 1? Anyone? So if you see, observe 300 and 700, the value is there, a tab, that are x and y coordinates. So that's the value of x and y coordinates. If I increase it to 1100 y coordinate, you guys can see 4 got tapped. You can check over there. So in this way, you can tap the touch and you can bypass. So imagine how we can do that. So for that, this is, I think I haven't seen anywhere this script. I have created my own. So this is integer 1, 300 and 700, integer 4, 300 and 1300. So I have created all the integer with all the coordinates which are available. So we just have to call this function and ask it to tap for me and everything and brute force the application. That's it. So for that, I have written a big one-liner over here. Let me quickly explain what it is. So it starts with for loop similar to 1 to 2, 5. Then what I did, I have splitted 1, 2, 2, 1, 2, 3, 4. I split it into 4 parts. 1 separate, 2 separate, 3 separate, 4 separate. Because if you see my integer int parameter over here, int, I want only one because it has to process Adb Shell input. So first I will do int 1. And if I want to process a 1, 2, 3, 4, I will first go to 1, Adb Shell input 1. Then 2, int 2, Adb Shell input 2. So in this way I splitted our payload into 4 parts. Then I have provided an integer as an input, and $x will be a first, it will come 1, then 2, come then 3, and 4. And that's way it will tap it for me, and it will bypass the application. So let's quickly see how this script will work. It's using a bash. Okay, so you guys can see here, it started tapping for me, and I can bypass the 2FA using this technique. So after some time, I'll get, once it got its code, it will get bypassed. So 1, 2, 3, 4 was the password, and you guys can see it. So this way you can bypass your 2FA, and this is a valid vulnerability, valid bugs. I think, so those points that we have covered in our esoteric vulnerabilities, that was the last bug. So key workshop takeaways that we learned from Sanjay, that how small code can be modified to bypass the checks, how frida can be used to bypass the root detection. Then we've seen how we can exploit esoteric vulnerabilities like Webview, which are mostly untouchable by bug bounty industry, as most of the people look for web application vulnerabilities. But these are also very interesting vulnerabilities. These you guys can check. We have seen how we can secure Android application using remote attacks like deep link are using. So you can go for an app link, or you can use whitelist a good application. And that's how to implement a secure deep links in Webview that we have seen in our, and that was end, guys. Thank you.